I'm Saadu Yusuf. I will be taking you through statistics for computing. The number of credit units is 2 for the course and year 1 and 4 semester. So in this course we will go through some modules. The course is divided into 7 modules, and the first module, which is module 1, we'll be discussing about statistics measure of central tendency and measures of position value. Then module 2, we'll be discussing about procedure for data collection in statistics. Or module 3, we'll be discussing about procedure for collection of statistical data. Module 4, we'll be discussing about the understand the method of data presentation. Module 5, we'll be discussing about the concept of set operation. Module 6, we'll be discussing about the concept of permutations and combination. Then lastly, we'll be discussing, which is module 7, we'll be discussing about the basic concept of probability. So to start with module 1, which is measure of central tendency. So when we are talking about measure of central tendency, we'll be discussing about the definition of statistics. So we start with definition of statistics. When we are talking about statistics, statistics is considered as a scientific method of data collection, organization, summarization, presenting, and analyzing. So in short word, when you want to define a statistic, you can say statistics can be defined as a scientific method of collecting, organizing, summarizing, presenting, and analyzing a data, as well as drawing a valid conclusion and making a reasonable decision on the basis of such analysis. Statistics play a vital role in planning and decision making, and the basis of every plan depends on accurate data that are available. So, having divided the statistics, we have different types of statistics which are divided into 2. One, we have descriptive statistics and we have inferential statistics. When we are talking about descriptive statistics only deal with summarization of data, or let's say summarization and description of a data. In other words, we can say descriptive statistics is used to describe the body of a data. Example of such are when we are talking about the frequency, the percentage, the graph, and the rest. So we can also have the measure of central tendency, then the measure of dispersion when we are talking about the variance, the standard deviation, range, and absolute deviation. This inferential statistics is another branch that is concerned with using the sample data to make an inference about the population. What am I saying in the essence is that this is a branch of statistics that is concerned with using the sample to make an inference or conclusion about the population from which the sample is done. Example of this are testing of hypothesis, estimation of parameter. This include the use of statistical procedure like correlation, regression analysis, ANOVA, which we are calling analysis of variance, the chi-square analysis, the t-test, and so on. Then we have the sources of data. Data can be sourced through 2 ways. The first one is primary data, the second one is secondary data. When we are talking about primary data deals with data collected from original source. These data are collected from experimental results or use of questionnaire. You can use different methods to collect this primary data. The bottom line here is that data must be originated by investigator himself. So that is primary data. When we are talking about secondary data, this data has been collected by someone before and you are extracting from that record. So we say secondary data are data collected from an existing record or data. Then we have the importance of statistics. The importance of statistics can be, can be understood by the phrase that statistics is crucial part of life, because in every day and every activities of human individual we apply statistics. So statistics helps us in making some decision. So when we are looking at statistics in psychology, psychology says the more you have a good command in statistics, the higher chance of success. Therefore, you need to know how important the statistics before starting to learn statistics. So, number one, statistics is very useful in social science. The variation in observation from time to time, object to object, place to place are what statistics does. Another one is statistics tools of regression and correlation analysis are used in social science to isolate the effect of this factor in every tested observation. Statistics are used to conduct social survey. Social surveys uses samples, techniques, and estimation theory. Moreover, sociology is crucial part of social study. So statistics also plays a crucial role in sociology. It helps in studying mortality, fertility, and population growth. That is some of the importance of statistics. Then, what are the uses of statistics? Statistics is a practical subject that applies to all human activities. Number one, when we look at the health sector, there are some diseases. Statistics are very important in health research and management. It's used to determine the prevalence of epidemiological diseases. When we look at the quality control in an environment or in a production company, they use statistics to control their product and evaluate the new product before that product are marketed. In engineering, statistics is used to determine the distribution and strength of a material for operational management. Optimal personnel assignment and resources collection are also vital in engineering, which statistics helps to do in engineering. Then when we look at educational sector, statistics is used for educational testing, measurement, and evaluation. It's also used for educational management and planning. In the sense, when you are having a statistical knowledge, it helps you to plan for your students, the prospective student, and those that are already in the educational sector. So you will be able to know those that are moving out of the sector, so as to plan for your labor market, as well as those that are coming in. Also, when we look at the agricultural sector, statistics are employed in agriculture to design analysis of experiment to determine the effect of new variety of fertilizer used in a product. Another area where you can apply statistics, which statistics is useful, is also in meteorology. Statistics is used in meteorology for prediction of weather condition at any given time or place. So, in describing all this, to the concentration of our value near the middle of a distribution, measure of central tendencies are very, very usual. Very, very important, because they describe the properties of a population. The word average, when we look at the word average, average is talking about a center of a data set. So when we are talking about an average of a particular set of observation, we are referring to center of a data set, and is a single value intended to present the distribution of a whole value. And in this average, we have three types of average that are commonly used. Namely, number one, we have the mean. Under the mean, we have the arithmetic mean, the geometric mean, and the harmonic mean and coding mean. Then the other measure of central tendency that we have is the median and the mode. Remember, I said we have three types of measure of central tendencies where we are talking about the mean. Under the mean are separated into different ways, where we have the arithmetic mean, geometric mean, harmonic mean, and coding mean. Then we now have the median and the mode. So let's start with the mean. When we are talking about the mean of a set of a data is obtained by adding all values of the data and divided by the number of data. Below we have different, like I said, we have different type of the mean. We have under the mean, we have arithmetic mean, geometric mean, then we have harmonic mean, then we have coding mean. So these are the these are the four types of the mean that we have. Then after mean we have what we call the median, and then we have mode. So to start with, we now start with our arithmetic mean. Arithmetic mean, what the mean does is just to add the set of value that we have together and divided by the number of data we have in that data set. So and when we are talking about the median is the middle number in a given set of a frequency. The median, when you arrange the set of data in order of magnitude, the one that falls at the middle will be your median. But if you have two values that falls inside, that falls at the center, what you just do is that you add the two values together, and divide by 2. That will give you your median. Then we have the mode. The mode is the third measure of central location, which is the simplest way. The mode is just the value that appear most. If you have the set of value and a particular value appears more than 1 or 2, the one that have the highest frequency is what we call our mode. And in a mode we have a different type of mode. There is one where we have a unimodal, that is when you have a set of value, a single value that appears more than once. Then you have bimodal, if you have two sets of values that appears with the same highest number of frequency. So that is when we have bimodal, that is when you have two values that appears more than once at the same frequency. Then we have trimodal, when you have three sets of value that appears with the same highest of frequency and they have the same value. Then we now go to computation of arithmetic mean. Like I said earlier, the arithmetic means is a series of data that is obtained by adding the value of data and divided by number of data. So let's go to the calculation aspect of it. So in our arithmetic mean, when you are given a set of observation, in this particular class, course, when we will be talking about the group and ungroup data. When we have a group data, there is a formula to get your arithmetic mean. Then when you have ungroup data, there is a way you obtain your mean. But let's start with ungroup data. If you have a set of observation, let's say x1, x2, x3 up to xn, and you are asked to find the mean for this set of data, your set of data your mean can be obtained with this by adding all the variables that we have and divide by number of variables. This means that your mean, which is called x bar, will be x1 plus x2 plus x3 plus up to xn divided by n. So mathematically, this can be written as summation of your x all over n. So your x bar will be sum of your x all over n. Then in a group data, okay, let's cite an example for this. For example, when you have a set of observation, like when we say we have 8, 9, 10, 3, 4. We are having 5 sets of observation and we're asked to compute the mean. So to compute the mean in this area is just that your x bar, which is sum of your x all over n, will be 8 plus 9 plus 10 plus 3 plus 4. Then you divide by number of observation 1, 2, 3, 4, 5. Divide by 5. So if you add all this together, this will give us 34 divided by 5. This will be equals to 6.8 if you divide it. So it will give us 6.8. So that is if you are dealing with on group data. So you can also have when we have a group data. So if we have a group data, our arithmetic mean is written as when you have a set of data, like when we have x1, x2, x3, x4 up to xn, and this value now has a frequency that appears with f1, f2, f3, f4 up to fn. So to now get the formula for the mean for this group data is just that your x bar will now be your first frequency multiplied by your first value f1 multiplied by x1 plus f2 multiplied by x2 plus f3 multiplied by x3 plus up to fn multiplied by xn, sorry, fn multiplied by xn divided by sum of your frequency, which is your f1 plus f2 plus f3 plus up to fn. So this can be summarized as your x bar to be equals to sum of your fx all over sum of your f. That is sum of your frequency. That is the multiplication of your frequency and your observation, if you add it together, divided by addition of all your frequency. So if you have this set of observation, this can also be a group data for, the formula for computing our group data for arithmetic mean. So we can have an example 2. Let's call that example 2. This one is example 1 for a group data. Example 1. So our arithmetic mean group data. Example 2. When we are having the set of observation, we are having 5, 8, 6, and 2. This is our x. Then that appears with the frequency 3, 2, 1, 3, 2, 4, and 1. So, and we are asked to compute the mean for this. So this implies that our mean which is sum of our frequency multiplied by x divided by sum of frequency, will now be equals to your first observation, your first frequency, which is 3, multiplied by first observation, which is 5, plus the next one, which will be 2 multiplied by 8, plus 4 multiplied by 6, plus 1 multiplied by 2, divided by addition of our frequency, that is 3 plus 2 plus 4 plus 1. So this will be equals to 15 plus 16 plus 24 plus 2, divided by, if we add this together, we are going to have 10 divided by 10. So this will give us, that is 31, 33, that is 57 divided by 10. So if we divide this by 10, we are going to have 5.7. That is the example 2 when we are having a group data. There is another example that we can also use, which we can call example 3. A set of observation can be given in a tabular form with the respected frequency. Let's have example 3, where we have in example 3. What they are asking us to do is that the table below shows the 5 employees of a computer company. Then we now have monthly wages per thousand, the number of employees. So the monthly wages, which represent our x, then the number of employees will represent our frequency. So in this, we are having it in this form. That is, this represent numbers of employee. Then we are having monthly wages, so per thousand. So under the first one, we are having 55, 65, 75, 85, 95, and we have 105, then we have 115. So that is the monthly wages. The number of employee in this frequency, we are having 8, 10, 16, 14, 10, 5, and 2. So we are asked to compute the arithmetic mean for this. So to compute the arithmetic mean, first thing that we first need to do is just to bring out our formula. So we work with our formula. So if we bring our formula out, which is our x bar, which is sum of frequency multiplied by x all over sum of our frequency. So with this, what we need here, we have given our x and we have given our frequency. So we just draw this in a tabular form, where we have the monthly wages, then we have numbers of employee. So here we have 55, 65, 75, 85, 95, 105, and 115. So we are having frequency here 8, 10, 16, 14, 10, 5, and 2. So the next column that we are going to have here is our f and x. This is our x, this is our f. So we multiply our f and x together. So if we multiply 55 by 8, we are going to have 440. So we can say that for better understanding, this one will be 8 because f comes first, multiplied by 55. So this will give us 440. So the next one will be 10 multiplied by 65, which will give us 650. The next one will be 16 multiplied by 75, which will give us 1200. Then the next one will be 85, 14 multiplied by 85, which will give us 1190. Then the next one will be 10 multiplied by 95, which will give us 950. Then the next one will be 5 multiplied by 105, which will give us 210. Then the last one, 5, will give us 230. So that is multiplication of our f and s. So to now get the sum of our fx, so we just add all these together. So our summation of fx will now be equals to 5,185. Then the lower side, which is sum of our frequency, sum of f, if we add all this together, we are going to have our sum of our frequency to be 65. If we add from here to here, it will give us 65. So therefore, our x bar, which is sum of f x all over sum of f, will be equals to 5185 divided by 65. So if we divide this by, if you divide 5,185 by 65, we are going to have 7692. If you divide this by this, we are going to have 7692. So if you multiply it by 1,000, so since we are talking about per thousand, so our result is going to be 79769.2. So the salary of that particular, monthly salary of that particular people that are working in computer company is expected to be 79,692. So that is when we are talking about the arithmetic mean for a group data. But if you look at this, the monthly wages has been given directly. The number of employees has been given directly. So there are some cases where we need to compute our x. So in that case, we go for the example 3. So in the example 3, we are having a sample that use the frequency distribution of the masses in kg in the table below to compute the main masses of 100 males students at College of Social Science and Administration. So these are given in a kg. So we are having this example is presented in this format. We are having masses in kg, then we are having frequency. It is our f. So at the first one we are having 60 to 62. So this is what we are having. We are having 60 to 62, 63 to 65, 66 to 68. I've jumped. So 69 to 71. Then last one will now be 71 to 73. 69, 70, 71. Then 72 to 76. 72, 73, 74, 72 to 74. Then under the frequency we are having 5, 18, 42, 27 and 8. So we are asked to find the mean for this. And remember, our formula is sum of our x bar, which is equals to sum of our fx all over sum of our f. So we are working with this formula. So we will present this in another table like we did earlier. So we have masses or mass, then we have the frequency. So we are having in mass we have 60 to 62, then we are having 63 to 65, 66 to 68, 69 to 71, then we are having 72 to 74. Then in the our respective frequency we are having 5, 18, 42, 27 and 8. So now to get, if you look at this, like previous example that we had, the mass, the x were given directly, but in this case we are having a class interval. So this ranges from 60 to 61. So now to get your x, so in this case we call x sometimes our midpoint. Midpoint. We can call it the midpoint. So how do we arrive at that midpoint? Is just what we just do is that you add the lower part of this side and the upper side of this side and you divide by 2. What I'm saying in the essence is that your x in this place will now be 60 plus 62 divided by 2, which will give you 61. So the next one will be 63 plus 65 divided by 2, which will give you 63. I mean, this plus this will give you 64. Then the next one will be 66 plus 68 divided by 2, which will give you, this will be 67. So the next one will be 69. So it will be 69 plus 71 divided by 2, which will give us 70. Then the last one will now be 72 plus 74 divided by 2, which will give us 73. So all these will now form our x. So the next one we are to go by is multiplying your f and your x. So this will now be the column of fx. So it will now be 5 multiplied by 61. So this will give us 365. Am I right? So 5 multiplied by 61, or the frequency. What do we have in the frequency? Sorry, the frequency is 8. The frequency is 5. So if you multiply this by 51, it will give you 305. That is 61 multiplied by 5. It will give us 305. So the next one will be 18 multiplied by 64, which will give us 1152. So the next one will be 42 multiplied by 67, which will give us 2814. Then the next one will be 27 multiplied by 70. So it will give us 1890. Then the next one will now be 8 multiplied by 73. So this will give us 584. So you now add all these together. So when you add, that is sum of our fx. So by adding this, it will be sum of our fx. This will be equals to 6,745. Then you add your f together. If you add your f together, you remember the question says 100 students. So if you add this together, it's supposed to be 100. So this will give us 100. So by that, we go back to our formula, which says that our x bar is equal to sum of f all over sum of fx all over sum of f. So this will now be equals to 6,745 divided by 100. So this will give you 67.45. So remember the unit that we were given. The question, the masses were in kg, so it will be 67.45 kilogram. So the arithmetic mean for this will be 67.45 kilogram. So that is the example when we are having our data in class interval, unlike when we have the raw score of x and the frequency. So that makes it easier to get our frequency, the arithmetic mean. So that is for arithmetic mean when we are having the group data and when we are having ungroup data. So the next one we'll be discussing will be on geometric mean. Having discussed the arithmetic mean, we are also having a geometric mean. What geometric mean does is that it measures the average of a set of products, and the calculation of which is commonly used to determine the performance result of an investment or portfolio. It is technically defined as the nth root product of n numbers. The geometric means must be used when working with percentage, which means we derive it from the value, while the standard arithmetic mean works with values themselves. When we are talking about geometric mean, it is written mathematically as this. Like I said earlier, that the mean find the average or the center point of a value, and the arithmetic mean is derived by adding the series of data together and divide by number of values that we have. But the geometric mean is just the end product, end root, geometric mean. So when we are having a set of value, let's say x1, x2, x3 up to xn, then we are asked to find the geometric mean of this. So this is simply written as geometric to be equals to n root of x1 multiplied by, let me use dot as multiplication, not to, so as we won't make a error or confused by my explanation. So x1 multiplied by x2 multiplied by x3 multiplied by up to multiplied by xn. That is when we are talking about the geometric mean. So this can also be written as, let's look at it. This n root of x1 multiplied by x2 multiplied by x3 multiplied, and this is when we are having ungroup data. Ungroup data. For all our explanation, we will be talking about the group data and the ungroup data. So when we are having ungroup data, this is the formula to generate our nth root. So this can also be written as your x1 multiplied by your x2 multiplied by your x3 multiplied by your x4 up to xn in power of 1 all over n. So to now get this, you first take the log of your geometric mean. So this simply means that your log of geometric mean will be equals to log of x1 plus log of x2 plus log of x3 up to log of xn. And mathematically, not to waste, because when we are taking the log, the power will come down, then this will be of the addition. So in a simple way, this can also be written as 1 over n sum of your log of your x. So when we now find this, after finding this in computational method, then you now take the antilog of this, it will now give you the actual value of your geometric mean. What I'm saying here is that let's look at the example so that we can use this to explain better. So we are having an example that says calculate the geometric mean for the set of number. So this set of number that we are having 8, 3, 5, 12 and 10. We are having 8, 3, 5, 10 and 12. So these are the values we are having. So we have to find the logarithm, the geometric mean of this. So what you just do is that you have a table. So this is our x, 8, 3, 5, 10, 12. So you take the log of it, log of your x. So the log of 8 will give us 0.9031. So if we take the log of 3, it will give us 0.4771. So if we take the log of 5, it will give us 0.6990. Then the log of 10 will give you 1. Then the log of 12 will give us 1.07. Log of 12 gives us 1.0792. So, and by the formula, our geometric mean is log log of our x. Then we have 1 over n. That is by the formula. So when we are having this, our n, how many observations are we given? 1, 2, 3, 4, 5. So our n equals to 5. Our n equals to 5. So we now take addition of this. That is sum of our log of x. So which is, when you add this together, we are going to have 4.1584. So therefore, our geometric mean will now be equals to 1 all over 5 multiplied by what is our sum, multiplied by 4.1584. So this will be, if you divide this by this, we are going to have 0.8317. So remember, this is just the logarithm. So to now get back to our geometric mean, so you now take the antilog of this. So our geometric mean itself will now be equals to antilog of 0.8317. So if you take the antilog of this, geometric mean will now be equals to 6.7870. So our geometric mean will be equals to 6.7870. And mind you, this is for ungroup data. So in the case where we have a group data, just like what I explained under the arithmetic mean. So if you have a group data, there is group data. So our geometric mean will be equals to n root, or let's say it in this way. When we are having a set of data of x1, x2, x3 up to xn, then with the frequency f1, f2, f3 up to fn. So our geometric mean will be n root of f1 x1 multiplied by f2 x2 multiplied by f3 x3 up to fn sn. So like what we did with the others, so this can be written as f1 x1 multiplied by f2 x2 multiplied by f3 x3 up to fn sn raised to power of 1 over n. So when we take the log of this also, so log of your geometric mean, this will be 1 over n into bracket log of f1 x1 plus log of f2 x2 plus log of f3 x3 up to log of xn fn. So this will be 1 over n into bracket sum of your f, that is 1 over n, sum of your log of fx, that is fi xi, where your I ranges from 1 to n. So when you get this, you now take the antilog of your results to get your geometric mean. So let's now look at example on how we can use this with a group data. So we have another set of example which says the table below shows the frequency distribution of mark obtained by students in mathematics test. So we have the mark and we have the frequency. So with the example, what we have there here is this. That is example 5. So we are having marks obtained by students. Then we are having frequency. So these marks are grouped from 0 to 10. Then we have 10 to 20. We have 20 to 30. 30 to 40. 40 to 50. Then the last one, 50 to 60. That is the marks that obtained by student. Then we now have the frequency of each marks. We are having 12, 18, 27, 20, then 17 and 6. So now to obtain the geometric mean for this, so what we first do is that we rearrange this. So we are having our table, we are having the marks, so which is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, then 50 to 60. Then we are having the frequency 12, 18, 27, 20, 17, and 6. So remember, when we are dealing with one example at the arithmetic mean, I said we are having a class interval in this place. So to now get your x, we don't have x here. So to now get our x, I said we call our x the midpoint. So to get your midpoint is just to add the lower side and the upper side and divide by 2. So which means we are having 0 plus 10 divided by 2. So this will give us 5. So the next one will be 10 plus 20 divided by 2, which will give us 15. So the next one will give us 25. The next one will be 35, 45. Then the last one will be 55. So this will now form our x. So the next one is we are working with the formula. So remember our geometric, log of geometric is equals to 1 over n sum of our f log of x, the log of x that we first need to find. So we take the log of 5, that's what we first need. So log of 5 will give us 0.6990. So log of 15 will give us 1.1761. Then if we take the log of 25, it will give us 1.3979. So the log of 35 will give us 1.5441. 5441. Log of 45 will give us 1.6532. Then log of 55 will give us 1.7404. So after getting the log of x, so we now go for f multiplied by log of our x. So we are multiplying the column of our f by the log of our x. So if we multiply 12 by 0.6990, we are going to have 8.3880. So if we multiply 18 by 1.1761, we are going to have 21.1698. 21.1698. The next one will be 27 multiplied by 1.3979. So this will give us 37.7433. So the next one, which is 20 multiplied by 1.5441, will give us 30.8820. 8820. Then the next one will be 17 multiplied by 1.6532, which give us 28.1044. 28.1044. Then the next one will be 6 multiplied by 1.7404, which give us 10.4424. 10.4424. So that will be f multiplied by log of x. So the next one, if we look at our formula, is 1 all over n multiplied by sum of f log of x. So we need to have the addition of f log x. So if we add all this together, we are having 132.7299. So then, so it's 136. It's 136.7299. So we now look at, we are having n here. So our n is also equals to sum of our f. So we just add our f together. If we add this together, we are going to have 100. So by that, we now come back to our log of f. So which is log of geometric, which is equals to 1 all over 100 multiplied by 136.7299. So this will give us 1 point. So if we divide this by 100, we are going to have 1.3673. So we now take the antilog of this to get your geometric mean. So our geometric mean will now be equals to antilog of 1.3673. So this will give us 21.2471. So if we take the antilog of this, it will give us 21.2471. So that is how to compute the geometric mean for the group data.